Welcome back, students. In this video, we will be solving the questions for quiz 2 on October 18th. The time allowed was 30 minutes and it's Math 262. The first question is on system of linear equation. It's asking you to graph the two lines and then label the intersection and intersection point. And also it's asking you to verify the answer by using any of the algebraic method. So I start by taking a look at these two equations. If you take a look at either of these two, you have to consider either x or y with the opposite and exact value for coefficients. So when you add them, it will cancel out. Here, if you look at it, if we multiply the second equation by 2, we will get the first equation is unchanged. The second one would be 4x plus 2y minus 8. And the negative 2y will be cancelled out by 2y. So the answer would be 5x minus 20. 5x minus 20 is a linear equation. Negative 20 moves to the other side. So that would be x would be 4. In order to find the y value, we can plug in this x as 4 in any of these two equations. I just used equation 1 as a preference, so I just plugged it in and found the value of y to be negative 4. So actually 4 and negative 4 is the intersection point. Okay? Now, in order to graph it, what we have to do, we start by considering each line separately. So for the first line, what I did, I have x and y. So x in the independent variable, I usually start by giving 0 or 1 or 2. So here I use 0. If we substitute x as 0, negative 2y minus 12 would be 0. So the y, negative 2y minus 12 would be 0. So if you solve this equation, the y would be negative 6. For the second point, I consider the x to be 4. And if you substitute in the same equation, you would get at y to be negative 4. Okay. Now, what I did next, I just drew two lines perpendicular. X, label it x, and y, this should be 90 degrees. This is point 0, 0. So my 2 points are 0 and negative 6 and 4 and negative 4. So 0 and negative 6. So negative 1, negative 2, negative 3, 4, 5, 6. This is negative 6. This is one of the points. And the other point is negative 4 and 4. So these are the 2 points. And I connected these two lines by my ruler because I wanted to be like precise as much as possible. Now for the second line, let's start by graphing it. 2x plus y minus 4. I will do it in green, x and y. So I give x as 0. The answer would be y minus 4. Y minus 4 equal to 0. So y would be 4. The other answer, I give y. I consider x to be 2. Okay, so 2 times 2 is 4. 4 minus 4, it's 0. So y is 0. Now I have 2 points, 0 and 4. 0 and 4. 1, 2, 3, 4. This is 1 point. The other point is 2 and 0. Okay, so this is your other point. And remember, your intersection point, it's 4 and negative 4. So this is exactly this point. Now let's draw the second line. Okay, if I draw the second line crossing from these 2 points, okay, I would see that, right? What is the intersection point here? This is the intersection point. It's 4 and negative 4, right? 4 and negative 4. And then what is the y-intercept? This is the y-intercept, which is 0 and 4. This is called the y-intercept, okay? We also can define the x-intercept. The x-intercept is when there is another y-intercept also here. So we could also have this y-intercept, it's 0 and -6. This is another y-intercept. You could also define x-intercept. It's when the two lines, one of the lines is actually intersecting with the x-axis. Okay, this was question 1. Question 2, it's asking you to solve the following system by algebra. Show the steps. So here I have 1, 2, 3 equations. Okay, so for 3 equations, and let's see, 2 variables here, but here there is 3 and here there is 3. So we have to consider the maximum number of variables. So the maximum number is 3 variable and 3 equation. So at the end, by solving this, we have to find the value of x, y, z, which is x, y, z. Okay, so let's start by considering a different combination. Okay, maybe the first combination I can consider it's 1 and 2, and then the other one that I can consider would be, let's consider, or consider this and this. Okay, this is one way of doing it. In this consideration, in this method, you have to make sure that you're consistent with eliminating a particular variable. Okay, another method, another actually way of solving this by being a little bit more creative, it's taking another look at the equations. Here, your equation is only consisted of 2 variables. Okay, remember, you need another equation with the same 2 variables to solve and find the value of x and y. And after that, you can just substitute the value of x and y maybe in this equation and get the value of x. Okay, so let's proceed with the creative method. So with this method, which I'm going to use the green color, I'm going to consider these 2 equations, which is 2x plus 3y minus z, it's equal to -6. The other one, x minus 2y minus 2z, it's equal to 1. Okay, this is the 2 equation. And here, the 2 variables I'm left with, it's x and y. So here, I have to do exactly the same. I have to keep x and y, and I have to get rid of the z. In order to do so, I multiply the top one with -2. So this one will turn into -4x, -4y, right? And then 2z equal to 0, equal to -2, -6 is plus 12. Now here I have x minus 2y minus 2z equals to 1. Now let's add them together. By adding, these two will cancel out. So I have -3x minus 8y equals to 13. As you can see here, I have one equation in terms of x and y here and another one in terms of the same 2 variable in here. Now I consider these 2 together. I mean this top one and then this one. Okay, I consider these 2 together, I solve it, and then I find the value of x and y. Okay, so I have 3x minus y equal to 5. The other one is -3x, -8y equals to 13. The good thing is here the coefficient of x is same and opposite sign, so this will cancel out. So it would be -9y, it's equal to 18. Y would be -2. Y it's -2, so I just substituted here 3x minus -2, it's plus 2, it's equal to 5. So 3x is equal to 3. From here, x is 1. So far, we found the value of x and y. I usually put a box around the final answer. So x is 1, y is -2. X is 1, y is -2. Now I have to find the value of z. I can consider the second equation. I'm gonna use this time. I'm gonna use a different color again. To find, I'm gonna use purple this time, and I'm gonna use the second equation. So 2 times x, 2 times 1, plus 3 times y minus z must be equal to negative 6, right? So let's solve this linear equation. It's 2 minus 6 minus z equals to negative 6. So negative 4, I move it to the other side. That would be positive 4 plus negative 6. It's negative 2. So z is 2. And now we found the value of the three variables, x being 1, y is negative 2, z is 2. I suggest not to stop here. Go back and check back your answer. Make sure the answers you found are correct. In order to do so, we have the value of x, y, and z. Let's plug it in into the third one and make sure we are correct. So x is 1, y is negative 2 times negative 2, it's plus 4, and z is negative 2 times 2, which is negative 4, and it must be equal to 1. Let's see, this and this will cancel out, and 1 is equal to 1. That means the values we found for x, y, and z are the exact values. I hope this helps you with getting more comfortable with systems of linear equation. I will be posting more videos, short videos, and more practice questions. See you in the next video.